Welcome to the program. I just came from some second graders, yes. They beat me up. But we are now in the third grade class, and we are going to need your third grade skills to go through the exercises today. Today we are talking carbon dioxide. How much is there? Well, I know. You talked about this last week. I can see your scribbles here. The little cute little plants and the CO2 and the sunlight and all the photosynthesis. Yes, we understand all that chlorophyll. Yes, that is good. You can't get much greener than carbon dioxide. Yes, I know. Well, we are going to discuss it anyway because it is a very hot topic today. Don't ask me why people are crazy. Well, you could be on the playground. You're talking about, I don't know, you're talking about the fundamental nature of the universe. You may be talking about, whatever. And this comes up. So you need some information to talk about. So we're going to help you get to the bottom of these informations that you should have in your back pocket. Yes, you could be on the playground. You could be, who knows, you could be at a fancy cocktail party, talking about these things. Well, I don't know. That's maybe the 8th graders. Well, I'm sorry. That was a bad joke. I take it back. Anyway, we're going to go to the internet to borrow some information. Here we go. Borrow this little chart here. It is so cute. Here you see this little chart. It starts down here and it goes way up here. And this represents the amount of carbon dioxide that we're looking for. Well, what does this mean? Well, it looks like it's starting very low and going through the roof. Well, it's time to panic. Not really. Let's fix this just to give you an idea here. We're going to fill out the rest of this chart here because it starts over here, but really it's 0 down here, 100, 200, 300. So this is really the total amount of CO2. It's actually starting here and trickling up all the way up here, you'll see. So, but still we're going to use their numbers because, well, we're going to use them no matter what. They'll get the point across. We are going to put this into perspective using their numbers, 398 ppms, which is parts per ems. That's millions. There you go. Over 1 million equal. This is where you use your arithmetic talents that you learned last week. Okay, what we have here is 1 foot. Because we are going to take their chart. When you look it up, it's about this size on your screen, about 3 inches. But the total chart that we have made here is about 12 inches. It gives us 1 foot. So it gives us a brilliant plan. We're going to use a swimming pool. A pool here. We're going to fill the pool with 1 foot of carbon dioxide, CO2. You see, to represent the amount of carbon dioxide in the atmosphere. And we're going to fill the rest of the pool with the other gases. That will give us an idea of how much carbon dioxide there is. That's what we're here for. Okay, well, first of all, we already determined there's 398 ppms. Write that down. Keep that in, put it in your pocket. Put it on your hand. Put it 398. Put it on your hand. That way, the first thing you know is how much carbon dioxide there is. Start with that. Now, as we learned last week, in your arithmetic equations, this times this equals this times this. I won't go any further. You should know that. By doing this, you can do it on pencil and paper. I don't care. Use a calculator. Doesn't matter. I'm going to fill it in for you. I think it's about 2513 feet. Yes, feet. Okay, so we're making some progress. What does that mean? Well, we need something to keep that into perspective. We already know we have 1 foot of carbon dioxide, and how much is left in the swimming pool. That's a lot. Yes, it is, Professor. We need something to represent it. In fact, we already have some visual aids. We're going to use a bucket for the 1 foot of carbon dioxide. There you go. I know. Keep that in mind. Okay, so what are we going to use to represent this? Looking up on the internet, a tall structure is what we need. Something which is very easy to look on the internet. We have found one already that I like. It's called the Empire State Building. No, it's huge. It's big. It's the tallest building in the world, at least for 40 years. I only have one. Where's the other? I need 2 because it's only 1,200. If you look, it's only 1,200. Half of that. Well, okay. We don't have one. Okay, so boys and girls, use your imagination. We have 2 of these to represent the total amount of the swimming pool. Well, still, I know you're getting ahead of me there. Well, that's crazy. Are you sure, Professor? I can't believe there's only this much. You're at the top of the Empire State Building. Yes, everyone knows the Empire State Building. Yes, they do. It's been used in every film in Hollywood for the last 50 years. Yeah, everyone knows. You go to the top. Remember Jonah and his father? They go up there cruising for chicks. Yeah, I know. We all do that. Anyway, you get up there. It looks like you're in an airplane. Think of 2 of them, you see. And look at the bottom there, at the sidewalk. Can you imagine this? Yes, that's all the CO2 there is. Had you been using your brain and made any effort to do any research before you came to class, you would find that it's a trace element. No, it's a trace gas. It's actually a molecule. But anyway, it's a trace gas. Yes, it's only like 1% of 1%. It's crazy, I know. Hey, look it up. Don't want to do your homework for you. That's what we're here for. Look at these numbers here. So, if somebody wants to know, you can look at these visual aids. Now, people say, well, but we are increasing the CO2 quite dramatically. Really? Okay, we'll look at these numbers too. Okay, we'll take this number here, about 315 or 20, going up to today's numbers by 398, whatever. That's about 80 units. And we have the number of years, which is not very many, but we're going to use it. 80 by 60 years comes up to 1.33 ppms. We're still talking ppms here, you see. Great. What is that? We need to put a number to that. Okay, so we convert this just like we did the other equation. We can take the 1.33 over 1 millions equals, well, let's see. Our total pool is the 25. Yeah, we know that. So we're trying to figure out what that is in real terms. Okay, do the math. I can't help you. Just do it. That turns out to be, if you do the math, multiply and divide, it turns out to be 0.00033. You're going to multiply it times 12 to bring it back to inches instead of feet because it's so small. You come out with 0.033 ... Some kind of number there. Well, that still doesn't help me. Well, I happen to have just the perfect item that we all carry of all ages and sizes. We have these things in our pockets. They're called credit cards, driver's license, hotel keys, gift cards. Well, there you go. Okay, that happens to be 0.03 of an inch. There you go. So the increase per year that we're talking about is not this, but this. Exactly. in a pool that is pretty deep. Here we go. Starting with 1 foot that we have today, we are adding this much. Can you imagine taking enough water to pour it in here to increase it by this much every year? Looking down with Jonah and his father. It's not very much, but hey, whatever. Go ahead. So, if someone comes to you and you say, how much is that? You can say, well, I have this number, $3.98, right here on my hand, and I have a bucket. Give them a bucket of popcorn. Give them your Blockbuster video card and tell them to go rent Sleepless in Seattle. And they might get it. There you go. We're done. Have a good time. I'm missing Antique Roadshow. Goodbye.